record it. Yeah. Once again, good morning to all my dear students. So today I am going to I am going to focus on dielectric properties of material. Dielectric properties of material. So what are the dielectric properties? So as you all know that the materials are classified into mainly three type, right? Solids. So the materials are three type that we already discussed. So now, based on the conductivity, we classify the three types. Conducting materials, conductors we call it. Insulating material, we call it insulators. Semiconducting material, we call it semiconductors. Conductors or the material which conduct, right? They have the free electrons, plenty of free electrons to conduct electricity. Okay. And the other one, conductors we already discussed now. So the other materials we call it as a insulator. So insulator, they do not conduct. They do not conduct. Here they do conduct. Okay. So now the question is, what are the third type of material? The next type of material, semiconductors. Semiconductors. So what are these type of material? Here again, it's a big issue when they become they do conduct, they do not conduct. So they behaves like a conductors and insulators. So when they behaves like a conductor at a higher temperature, room temperature, or at zero degrees centigrade, 0 K, I would say, they behaves like insulators. Whereas conductor at all other temperature, they conduct especially higher temperature, they conduct. Lower temperature, they act like an insulator. So semiconductors are, don't tell that if someone asks you what are the semiconductors, you should tell that semiconductors are the material which behaves like a conductor as well as the insulator, but they behaves like a conductor at higher temperature, behaves like insulator at lower temperature, which is 0 K. This is what you have to tell. And conductors, they have enough electrons to conduct. Insulator, they do not have any electron to conduct. Completely zero electricity. So the next one is actually generated from the insulators. So which is actually dielectric material. So what is that type of material? Dielectric material. So these are the material or the insulator, but they do conduct, at at certain electric field, or when you apply the when we apply the when we apply the electricity when you apply the electricity or electric field. So whenever you apply the electric field, they do conduct. So insulating material, dielectric materials are the insulating material. They conduct only when you apply the electric field. Such type of materials are called dielectric materials. Now is it clear? Everybody understood? Yeah?
Yes, sir.
So now everybody understood this definition of dielectric material. They do conduct only when the electric field is present. Otherwise, they are insulated, they don't. So that is what introduction. So coming to the, you can see here, How they conduct is the question. So here basically, when you want to apply the electric field, you need the electrodes. Definitely, you need to apply the positive and negative electrode plates, you can solve. And this is the dielectric material. This is the dielectric material. So when you apply the 1 volt potential difference between these two negative plate and positive plate, and what happened? The flow should start from positive terminal to the negative terminal, right? The electron should move from positive to the negative side, or no? They do no. It's completely opposite, Nana. So electron should not go to negative, should go to positive. But in dielectric material, it's completely reverse process. In general, in general, electron should attracted by the positive plate. Okay, so that should go like this, positive. But here, what happened? It's a forcibly. So the ion dielectric in dielectric materials, here you have the kind of like a positive and negative ions are there. The flow should start from positive terminal to negative terminal. But here just plate. But what is this? This is dielectric material. Within the dielectric material, the direction should go from the positive side to the negative side. Okay, is it clear? You have to ask first year student. See students, please ask. You have to interact with me. And here you can also see a when you don't apply the electric field, you have to remember all these diagrams. In the exam, you have to draw it and explain it. So, in dielectric material, when you don't have the electric field, the dipoles, what we call it, tell me, positive and negative, they are all together in the dielectric material. These are called dipoles. So we don't call positive or negative here. We call it dipoles. They all together. In the before slide also, we discussed that the dipoles are moving from positive plate to the negative plate. Okay. And here, all these are the dipoles. One is positive ion, the other one is negative ion. So when you don't apply the electric field, they are randomly aligned. Dipoles are aligned in a random direction. There is no specific direction. But when you apply the electric field E naught, they are in the direction of the field. They all aligned in a field direction. So this is actually called polarization. Polarization, kind of like a magnetization. Magnetization. So this is actually, we talk about a magnetic dipole. In this case, electric dipole. So electric polarization, magnetic polarization is kind of magnetic polarization. We don't call it magnetization. Involves the magnetic dipole. Polarization involves the electric dipoles. So no net field to the right, and it should be so like this. So the total field also generated within the material, the net field should be this direction. Even if you apply the this direction, there is an inside internal field in use, which is this direction. Okay. So remember this. So what are the present? What are the ions are present? What are the present in the dielectric material? Dipoles. When you don't apply the field, what is the orientation of the dipole? They are random. When you apply the field, what is the direction? They are aligned in a field direction. Is it clear? Yes?
Yes, sir.
Yes, sir.
Yeah. So that is, you should remember that. The simple mechanism, dielectric material. So we already talked about the the dielectric material or how they will get, like, all this is, I don't need to teach again. Yesterday I already, in the previous class, we already discussed all the stuff. What is the, this band gap, a conduction band, valency band. This is the energy gap. If the energy gap is zero, we have the conductors, right? If the energy gap is less than 2, so we call it as a semiconducting material. If energy gap is greater than 2, we call it as insulators. So these stuff we already discussed, and also we have mentioned this solids which have energy gap 3, more than 3 actually, are termed as an insulator. Okay, so in this material almost all they don't conduct it any all, like though the in insulators they don't conduct. Okay, dielectrics are also called insulator. As I mentioned, they are also called insulators. So the poor conductor, you can also call it as a poor conductor of electricity. They don't conduct easily, however they conduct only in the presence of electric field. So dielectric materials also important bits in competitive exams. Dielectrics are also non-metallic material. That means they are not a metals. They are not a metal. What they do have? They have the high specific resistance. What they have? High specific resistance and negative temperature and coefficient of resistance and a large insulation resistance. All these are the important points to remember for competitive exams. When someone asks you which of the following is not true in the case of dielectric material, they mention high specific resistance, negative temperature coefficient, and small insulation resistance. So small insulation resistance is the answer. So you should always remember that. Insulation resistance will be affected by, what are the insulation resistance which is affected by? It affected by the moisture and temperature. Moisture is the kind of like humidity. Okay, humidity kind of moisture, water molecules are there. So definitely they affect a lot. Temperature also affect. So let me go for the next. So already you know that here also you already, I mean, we already discussed this slide also. The materials already I mentioned, they are non-conduct, there are non-metals or non-conducting materials. All this is like examples are there: wood, ebonite, mica, and they are the also called insulating materials. Sometimes if you want to keep insulating layer around the conducting wire, we use this dielectric material. And we also use the dielectric material storing the charge, storage devices, like C is equal to epsilon A by D. This is the, we discussed in capacitors. So I think in the paper 3, in the electrodynamics paper also you are discussing that. So epsilon A by D. So when I apply the dielectric material, it becomes K epsilon A by D, which means K times increasing capacity, which means K times increasing the storage of charge. So charge increased by K times. So when you place the dielectric material between the plates, suppose when you keep the dielectric material between the plates, definitely what we have, what ఏమవుతుంది, k టైమ్స్ ఇంక్రీజ్ అవుతుంది. ఏమవుతుంది, చార్జ్ k టైమ్స్ ఇంక్రీజ్ అవుతుంది, కెపాసిటీ కూడా k టైమ్స్ ఇంక్రీజ్ అవుతుంది. Why it's improve? Anybody want to share idea? This is very important. So what I'm trying to say is, this is a capacitor. I'm keeping dielectric material. So plus minus say. Why? When I keep the dielectric constant is K, does anyone want to share your ideas? I'm saying that K times increase. When I keep the dielectric material between the plates of capacitor, it is increasing by K times according to this formula. Why? Does anybody want to discuss it? Yes, Sushma, do you understand this concept? చెప్తారా ఎందుకు ఇంక్రీజ్ అవుతుందో? ఎనీబడి?
ఎలక్ట్రిసిటీ ప్రొడ్యూసింగ్ ఎలక్ట్రిసిటీ ప్రొడ్యూస్ అవ్వడం వల్ల అది ఇంక్రీజ్ అవుతుంది.
ఎలక్ట్రిసిటీ ప్రొడ్యూస్ అవ్వడం వల్ల ఇక్కడ పాజిటివ్ ఉన్నాయి అనుకుందాం, ఇక్కడ నెగిటివ్ ఉన్నాయమ్మా. సో బట్ దే పాస్ త్రూ దిస్ మెటీరియల్, రైట్? సో వెన్ యూ, దీస్ ఆర్ ద ప్లేట్స్, వెన్ యూ అప్లై ద ఎలక్ట్రిక్ ఫీల్డ్, so the ions passing through this material, right? Right. So when you apply the electric field, what happens? Insulator react like a insulator also conduct, right? Like the electric material also conduct, right? Dielectric material అంటే ఏంటి? ఎలక్ట్రిక్ ఫీల్డ్ ఉన్నప్పుడు మాత్రమే పనిచేసేది కదా, right? So when you apply the electric field here, it also affect the dielectric material because ions can passes through this material. So ఇందులో ఉన్న ions కూడా ఏమైతే induce అవుతాయి. So they form a dipoles. The ions inside the dielectric material induces and increase the number of charge carrier between these two plates. అంటే ఈ డైఎలక్ట్రిక్ మెటీరియల్లో చార్జ్ క్యారియర్స్ మనకు యాక్టివేట్ అవుతాయి ఇన్ ద ప్రజెన్స్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్. అందుకే కెపాసిటర్స్ మధ్యలో మనము బై ప్లేసింగ్ ద డైఎలక్ట్రిక్ మెటీరియల్ వీ కెన్ ఇంక్రీజ్ ద స్టోరేజ్ కెపాసిటీ. ఓకేనా?
ఓకే సార్.
సో యా, ఇవన్నీ కూడా ఇంపార్టెంట్ పాయింట్. 4 మార్క్స్ క్వశ్చన్ వస్తుంది. ప్రాపర్టీస్ ఆఫ్ డైఎలక్ట్రిక్ మెటీరియల్స్. You always need to remember all these points. There are a lot of points, we discussed it. At least you need to remember few of them. So yeah, okay. So coming to the dipole moment, I think we left last class here. So dipole moment, oh, already 10 minutes. So dipole moment is what? It's a P is equal to Q times distance. So it's a dipole, we call it dipole because the dipole is the one when you place the two charges with a distance d, the product of the charge times distance is called dipole moment. If someone asks you what is the dipole moment, what is the dipole? It's a dipole moment is the product of the charge times distance between the charge. So simply P is equal to Q into D. So note down this. I'm going to change it. So permittivity. So what is the permittivity? Permittivity represent dielectric property of the medium. It indicates easily polarizable nature of the material. Its units are Faraday per meter. So if the permittivity is more, what happened? All dipoles are aligned in a field direction. Like this, highly polarized material. So completely all dipoles align in a field direction. Okay. So permittivity is the property of the material of the medium. It indicates polarizable nature or capacity of the polarizable nature of the material. If this is a greater than 1, we can say that the material is electrically polarized, highly polarized. That means all the dipoles are aligned in a field direction. So dielectric constant dielectric constant of the material is determined by its dielectric constant. It's a measurable of the polarization of direct. What is the it's kind of a capacity. It's kind of capacity of the Polarization. So dielectric constant tells you the how much polarized, how many dipoles are aligned in a field direction. What is the capacity of the polarization? That can tells the dielectric constant. So polarization is kind of parallelly we talk about magnetization. So magnetization is magnetic dipole in a line in a field direction. When the electric dipole align in a field direction, we call it polarization. If the polarization is more, means all the dipoles are aligned in a field direction. In this case, so this constant, dielectric constant, can tells the capacity of the polarization, and which is defined as it's a ratio. It doesn't have any unit. Absolute permittivity, which is this one, to the permittivity of the free space. Suppose this is a glass or water, to the free space. Whatever the epsilon for the material to the for the free space, that is called dielectric constant. Dielectric constant is the constant, and it is a ratio of the permittivity of the medium to the permittivity of the free space. All these constants are related to the polarization concept. So I'm going to change it slide. uh, So now moving into the polarization, and this is also very important term to remember. So what is the polarization? As I mentioned, it is a process of producing electric dipole inside the dielectric by the application of the electric field is called polarization of the dielectrics. So polarization is it is a process of producing the dipoles. It is a process of producing the dipoles in the dielectric material by the application of the electric material. How do we get the dipoles in the dielectric material? When you apply the electric field. So it is a process of producing the electric dipoles by the application of the electric field is called polarization. Is it clear, Shishma?
Yes, sir.
So polarization ante enti, it's a kind of like how much dipoles are you are producing. How do we produce it? You have to apply the electric field. Which
Electric
materials are
field.
the right material to produce the dipole? Dielectric material. So in the process of producing the dipoles inside the dielectric by the application of electric field is called polarization. Remember that statement.
Polarization.
Very important. You have to keep in the brain. You have to activate your chip. నీ బ్రెయిన్ చిప్లో పెట్టుకోండి, ఏదో నోటు చేసుకుని వదిలేయడం కాదు. ఓకే. అండ్
Yes.
polarizability, it's kind of like capacity of the polarization. It is found that average dipole momentum field, average dipole moment of the field is called polarizability. It is defined as this. It is defined as average dipole moment to the applied field. So alpha is equal to dipole moment for the electric field. So mu is the dipole moment. Mu is the dipole moment which is defined as a q into d. So polarizability, it is a ratio of the dipole moment to the electric field. Did you note down? Yes? Did you?
Yes, sir.
Yeah, please copy. Don't leave it. Every question is important. We don't know which question comes. And I think last but not least, uh, active and passive dielectrics. So active and passive dielectrics. You can imagine active students and passive students. Like example, active students always interact. Active students always participate in the discussion during the class period. Whereas the passive student, they don't. They just sit like anything. They just hear it, whether they understand or not. So passive is a kind of difference, Active is always involving in the discussion. So definitely active student always understand 100%. So passive student could be, we don't know, until unless if he participate, until unless if he write exam. So dielectric materials are classified into two types, active and passive. So active, when the dielectric material is kept in external field, if it conduct, if it activate when you apply the electricity, we call it as a active dielectric material. Even when you apply the electric field, if they don't conduct, if they don't show any charges, still like they are insulator, we call it as a passive. Glass, mica, rubber, they don't conduct at all. But here water they conduct H2O, right? They do conduct. So in the presence of electric field, water can conduct. That is called active dielectric. But in case of rubber, even if you place this in the electric field, it doesn't conduct rubber. So that is the passive. I think the time is, we have less than 1 minute. I don't know whether I can able to finish the slide. One more slide is there, but anyway, I think that's nothing is important here. Chapter is over. Okay, you can prepare it. I would say electric susceptibility is the dimensionless. This is also important, Anna. Susceptibility is the dimensionless proportionality constant that indicates the degree of how much polarized sample అనేది మనకి ఇక్కడ susceptibility చెప్తుంది. How even the magnetism also it is there, susceptibility. The how the degree of polarization can indicate the susceptibility. Okay, and there are some examples are there of applications of dielectrics. Liquid dielectric, gas dielectrics are there.